this is mostly, I'll be showing some code, mostly on slides, which is the best way to talk about code, is on slides, not inside Visual Studio. And I'm going to talk a little bit about techniques and things that you can do to kind of refactor code bases and why we need to refactor code bases and things like that. So I always say apply the law of 2 feet. So basically it means that if you feel you're in the wrong session, or if you feel that everything I'm talking about you already know, well, just stay put. No, I'm kidding, you can get up and leave. I won't be offended. I have a good way to remember faces though. So. Right, can somebody tell me what this is? Oh, the other thing, it's going to be, it's early, it's 8:30 in the morning, you guys are still asleep. How many of you have coffee? How many of you are still drinking the beer? So we won't make this too much of a rough session. The next one is going to be rough, which I'm not giving. So, what's this? Greenfield, which represents what?
It's a very new program.
Very new program, which represents beauty, which represents I get to do absolutely anything I want, right? How many of you work in this field? Yeah. How many of you work in this field? Right. The vast majority of us, because as soon as we start something, it's like a week's gone in and it turns into this. And you're like, oh God, I wish I could have started this again using something else or a different way. So most of our life we're spending in this kind of place, which is kind of stinky and it's not nice. But nonetheless, we've got to make the best out of it. So the question arises of, do we need to refactor, and why do we need to refactor? I'm assuming everybody knows here what refactoring is, right? Yeah, okay, good. So we all know what refactoring is. So can you tell me why we need to refactor? Anybody? Let's make this interactive.
Because I can write the best code.
Good point. So you can take other people's shitty code and make it good. You write the best code. What else? To make it readable. What else? How many of you refactor? Okay. I would say the main reason for me is to improve understanding of someone else's code. Were you at Dino's session last night here? Who was at Dino's session last night that was talking about writing code that other people can understand? So that's a very important thing, because if you look at our life, the amount of time, and this is true, this is based on scientific evidence. Okay, it's not, but it's quite accurate. The amount of time that we spend writing code versus the amount of time we spend reading code is quite substantial. We spend a lot of time reading code. You know, trying to understand what we're doing, what we're trying to extend, what we're trying to fix. It's a lot of time that we spend reading code. And if you take this time, the amount of time of what the hell is written here versus, oh, I understand what's being done here, is also large, right? There's, again, so much time of what was he trying to do? You know, so much of that. And a lot of it is because we have different styles, we rewrite in different ways, then technologies appear and we decide that it's great to use these technologies. For instance, LINQ. How many of you know LINQ? Right? Everything suddenly started to be written in LINQ. In fact, I work for JetBrains and we have a tool, ReSharper, and we have this convert to LINQ. And we thought, oh, there's a bloody good idea to, you know, automate this. No, it was not. ReSharper, when you convert to LINQ, produces some of the most horrendously unreadable code ever. So we introduced now a take LINQ and convert to for expression, which wasn't Control-Z. I mean, you know, take existing code. Because it's really hard sometimes to read this kind of readable, unreadable code. So that's one reason, to make code clearer to read. Would you agree with that? Okay, good. Another reason. What else? Building new features. So why would I refactor to build new features?
Make it easier to build new features.
Make it easier to build new features. How would I make that easier? By refactoring.
Simpler design.
Simpler design. What else?
Experience.
What?
Experience from the past. What is wrong or what is bad to handle?
Okay, yeah, fair enough. Would you say minimizing change? All of that is pretty much related to minimizing change. No? So if I have code and I want to build a new feature, what is the biggest issue I have with building a new feature? Assuming that I know exactly how to build that feature and I have the perfect requirements on an existing code base, what is the biggest problem sometimes we face when we want to introduce a new feature? It makes it unstable, right? Because how many times have you written code or added features to existing code base and it's come out beautiful, perfect, and hasn't broken anything? Never, right? And as the code base grows, this becomes bigger. It becomes a bigger problem. If you look at this graph of a project lifetime, everything grows, right? I mean, absolutely everything. We have the well, that actually says understanding, but you can't understand it. Oh, isn't that ironic? That says understanding. That goes higher. It's harder to understand, which means that it's harder to change, which means that it costs more. Over the lifetime of a project, everything just increases and increases and increases. And a lot of that has to do with understanding and also change. Every time I introduce a change to my code base, I run the potential of breaking something, especially if I don't have unit tests. How many people unit test? Right. The rest, implement, ship, and pray. That's the other process. Especially if I don't have unit testing, I make some changes, I add a feature, and that can potentially break something else. And I've had this happen to me millions of times. I'm a really bad programmer. Fine, I've had it happen to me a lot. In fact, there's one instance which I always use as an example of how badly you can screw up, is we used to do this software for print industry, which is very big in Germany. And in the print industry, you have to print out sheets of paper, and you do like magazines. So you say, for example, a 64-page magazine, you take a big sheet and you divide it up into 8 pages, and then you have to fold it in a special way, print on both sides, etc., etc. And one of the things that you have to do also is put a protective varnish on it after you print it so that the ink doesn't run, right? The protective varnish on a sheet of maybe, let's say, an A3 or something like that can cost you 0.005 cents, right? But on a 128-page magazine that you're doing 10,000 runs adds up to some money. So we had this software which was not unit tested, and it was very, very complex. It was an ERP, and it would do these calculations, and we went and added some new feature, and when we added that new feature, lo and behold, what did it do? Somehow, some if branch didn't get executed, and it stopped calculating varnish costs. And after a week, we realized, right? Luckily, we had only deployed it to one customer who happened to also be my partner. So only he was affected by losing something like 25 or 30,000 euros, right? No one else was. We were lucky in that my partner was a nice guy that didn't sue me, and also we didn't deploy it to all of the other customers. And we had absolutely nothing to do with varnishing. What we introduced had absolutely nothing to do with varnishing, because you cannot predict the consequences of changing code. You do not know what you're going to affect by changing some code. So it is very important to refactor in order to minimize change. And one of the key things in code, in creating and maintaining legacy code, is minimizing change. Creating systems, refactoring systems to create other systems that have minimum impact when we introduce new features or fix bugs. So I would sum up, in my opinion at least, that the main 2 reasons that I refactor is to improve understanding, which ultimately produces decreases the cost of implementing new features, and also minimize change. The next question, of course, that comes up is, when do we refactor? Right? Many a times we say, well, we start with a project, or we've got a new version of that project, and we've got to get out these X features. And as we're going along, we start to see that there are issues. And we say, well, we don't have time to do this now. We've estimated that this feature is going to take 5 days, and therefore, we'll just hack around this, put a little to-do, and move on. How many of you have done that in the past? Everyone's done that, right? And we say that one day, we will create an iteration or a sprint or take time off of 10 days and say, let's refactor. That is going to be the big refactoring day, right? How many times does that happen? It never happens. And when we're close to it happening, we'll just put it on for tomorrow. And tomorrow, a mystical land where 99% of all human productivity, motivation, and achievement is stored. So true, isn't it? I'll just delay this for tomorrow. And tomorrow never comes. So point is that I don't find it very productive also to say, I'm going to dedicate a week or 2 weeks or 3 weeks to refactoring, because it just doesn't work. Just doesn't work. Rarely do you have time in a project to say, let's just take a month off and refactor. You just can't. Especially if you're doing products. Especially if you're doing products. I mean, for example, I'll give you the experience of ReSharper. In ReSharper 5, we shipped with a lot of new features. And then ReSharper 6, I would say around 50 or 60% of the time of ReSharper 6 was spent refactoring. Right? Cleaning up the code base. But at the same time, we had to introduce new features. Because we couldn't just ship ReSharper 6 and say, what's new? Well, it's much cleaner inside. But you can't. People don't care. Even though really they should care, because it's cleaner inside, which means that there's less possibility of things breaking when we introduce new features or when we fix a bug, or it will go faster because there was a hell of a lot of increase. But you just can't say, well, it's just cleaner. On the outside, it's exactly the same, but inside, it's much nicer. And here, pay me 200 euros. You can't. So we had to refactor and introduce new features at the same time. So you can't do that. You can't just take 6 months off a project and say, right, now I'm going to sit and clean it. And there's no way in hell you're going to sell this to management. Well, you see, the thing is that if I do this, next time the customer asks for a feature, it'll be much better. It doesn't work. It doesn't work. This is my similar kind of to my kids' wardrobe, right? If you have kids, it kind of normally the vast majority of houses look like this. And of course, what happens, I'm actually amazed at them sometimes. It's like they want to play with a toy and they find all the little pieces in all different areas, right? But it takes them like 2 hours to find all the pieces, and then they have 10 minutes playtime, and then they lose it all again. And I say to them, just try and keep things tidy so that next time you know, when you're looking for something, you know exactly where to look. And it's much the same way with code. If we keep things tidy, if we keep things organized, we exactly know where to look for things. Of course, the problem is that, yeah, I didn't make this mess. Why should I clean it up, right? Which is the problem that we have. No, let Joe clean it up. He wrote it. But ultimately, if we have a situation like this, it's much better. And this raises another problem. On many teams, I've noticed that they kind of, one person can be responsible for a specific area or feature of a project. So what does Joe do? Well, he implements, I don't know, CSS support, or he does the invoicing section. And Joe knows everything about the invoicing section. And if there's a bug, Joe will fix the bug. And if there's a new feature, Joe will implement that new feature. Do you suffer that problem on your teams? Right? And I say it's a problem. Why is it a problem? Because in the short term, it feels very good. It feels like a fabulous idea. Joe knows everything there is to know about invoices. So Joe writes everything about invoices, and Joe writes with his code style, and Joe does everything himself, and Joe fixes it until Joe goes on holiday, then we're screwed, and if Joe dies, it's the end of the world. Right? You've heard that saying of the bus number or the truck number, no? Is how many members of your team need to be run over by a truck for the project to fail. I know it's deep, dark humor, but nonetheless, it's true, right? I mean, if you have a team of 10 and 2 people get run over by a truck, or okay, let's be nicer, they move to Hawaii, and your project is kind of left there like, oh, now what? Joe knew everything. It's a problem. That's why we try and do certain things in a way so that we don't have dependency on a single individual, such as, for instance, automating build processes. Right? No one in their right mind today does a manual build process. You automate it. Not only because you don't want to have a dependency on one person, but also because humans make mistakes. Machines don't. And a build process is 10 steps, and it doesn't matter. The more you do the same steps over and over again, the more chances there are that you will fail. It's like driving. If all you do is drive up and down the same road, you start to gain so much confidence, and that's where you're going to end up having an accident. Right? It's the same with build processes. It's that dependency we're trying to eliminate. So what happens is that we have teams that create little silos that are focused on one person implementing one feature or one area. And what happens is that side effects of this is that, first of all, no one else can read that code because no one else reviews it, because why should they? They're not focusing on that. They're not fixing anything there. They're not fixing any bugs or implementing new features, so why should they care about that code? We'll let Joe do it. And that's wrong, because we don't want to have a dependency on Joe. And not only for our sake or the team's sake or the project's sake, but for Joe's sake. People get bored working on the same thing year after year after year after year. They need to move. They need to evolve. They need to educate themselves. They need to find other things. They need to experiment. They need to learn from other developers. If all you're doing is working on your area, that's a problem. So even if it's not your mess, it should be, you should be responsible, just like anyone else, to clean it up. Unfortunately, this also leads to another problem, which is, it's called ego, right? Wait a minute, you took my code and you rewrote it like this? I've had that issue. A friend of mine used to say, the best thing you can do on a team is when you come to work in the morning, leave your ego at the door and pick it up on the way out, right? Because that is a big issue that we have with developers and people. You know, you do work and someone else comes and says, well, that's not that nice, let's just do it this way. There is a clash, right? And then that exists in any job, anything you do, right? Someone fixes a tire on a wheel and someone else comes and says, nope, let me just change the way you fix that. It's going to offend the person. But we got to learn to communicate and deal with this issue. But that's another talk. So before we start anything, before we start all of this refactoring and that, there's a few minimum required steps that we need to take. First of all, there's this concept of source control, which I'm hoping and assuming that everybody does use. Yes? And as I said yesterday, Visual Source Safe does not count as source control, nor does folders that I had a customer, which, and I'm not talking about someone like 15 years ago. No, I'm talking about 2 years ago. Their source, no, actually this customer is still doing it. They're still doing it. And if I told you the name of the customer, you would collapse right here. Because it's one of the largest companies worldwide. But anyway, they've got a little department and they're doing some internal stuff. I said, what are you using for source control? Like, oh, well, we've got our own mechanism. I'm like, what's that? Well, we take files, we zip them, we give the zip file a name, which is the date, time, and hour, date, time, and then we store it on a shared folder. And we have a little text file inside the zip file with comments of what those changes contain. I mean, I can't begin to think like, how could I tell these people that they're doing it wrong, right? Do you know source control exists? Yeah, but it's too complicated for us. Because this is so much easier, right? So much more fascinating. Yeah, everybody does use source control, yes? Anybody still uses zip files with? No, good. And automation. That, again, automation is very important. You need to try and automate as many things as you can in your life. Source control allows undos, and what it also allows you to do is refactor without fear. And it also removes comments. Because I often find it fascinating that people use source control, and then I find this in code. Right? A method completely commented out and checked in. What is that? Well, I've made some changes and this method's no longer required. So why is it there? Well, in case I screwed up. Yeah, but you just checked in a version. Why don't you just roll back? Oh, it's easier like this. Okay, so now I come across this and I read it and I'm like, why is this commented? What should I do? There's no, name of who commented it or the reason, because, well, that's a commit message, right? The source control does that for you. So why are you checking in code with comments? This all contributes to misunderstandings and decreasing readability. What is worse than this is this. This is horrendous. Because I have a method that has some information, has some code, and then there's a line commented out. What does this mean? Don't I need to set up defaults anymore? And I had this situation occur to me with Objective-C. We were in a company where we were just starting out doing some iPhone development, and we made an application for talking to Exchange Server, right? And the guy that wrote it, his name was not Joe, it was Jose, which is Joe in Spanish. He left. One way of putting it, he left. And so I had to take this over, which wasn't a problem because, everything was working fine and we were selling it. And one day I get a email support through the shop and reviews that this doesn't work. I'm like, oh, okay. So I fire up Apple and I fire up the Mac and I'm like, where do I look? So what's the problem? It doesn't connect, it just doesn't sync. Like, okay. And I start to look through the code, and I kid you not, there's a line to a method called connect that is commented out. I'm like, this can't be. I mean, how can people be using this with this version? This is not a newer version, it's the exact version that's shipped, and this line commented out, this connect. It can't be. So of course, what was my natural reaction? I uncommented the line, built it, shipped it, waited 3 weeks for the update on the App Store. No, it still doesn't work. Damn. After about 2 months, we figured out that, because the other problem is that people aren't immediate, especially people that use an iPhone app that they've paid 50 cents for. They don't get back to you immediately. We found out that the problem wasn't that line connect. It was that the guy was using a newer version of Exchange Server, and the protocol had changed, so it was just failing to connect, right? Now, yes, I admit that I'm not the brightest developer in the world, but when someone says to you, it doesn't sync, and you open up the code base, and the first thing you see is a line that says connect, and it's commented out, it just can set you down the wrong path, right? So what is the purpose of leaving that line in there? And obviously, I did drill into the method, and it did say setting the port and all that, and it was connecting and all that, yeah, right? Anyway. This is better. I've removed setup because it's causing an issue on second and consecutive calls. Right, but for that, again, we've got source control. Just remove that code and check it in as a comment to source control. Because this is even better. Now I set a date, time, author, but again, you can do this all in source control. Right? And then we figure, the problem is that we do these things, and then in source control, in the commit messages, we fix some stuff, right? That's our message. Fix some stuff. Have you guys seen the dailycommits.com? Who's seen the daily commits? There's a website that's daily commits, and what it does, it pulls the daily commit messages from GitHub that have obscenity in the commit messages. And you should read through some of them. There's so much frustration and anger in us as developers. So, automation, one of the issues again is, oh, this is too hard to automate. So that's why we'll just do it manually. Enough said, I can't. There's no other words to say about that. Okay, so now let's get to actual refactoring. And the first step that's important is impact analysis. So before I refactor, I need to know what it is that I'm going to break. Because that's what happens when we refactor. We break things, especially if we don't have tests. We end up breaking things, and that is very important. That is another good reason to have tests, right? Tests go from writing out code to becoming a unit test, verification, and then as soon as they become the unit test, and it passes, it just immediately changes life form and it becomes a regression test, making sure that any other changes, that unit test is there. So it's got 3 purposes in life. And still, half of the room doesn't unit test. By the way, why don't you unit test? Those that don't unit test, why? Okay, I'll do this another way. How many of you unit test? How many of you think unit testing is good? Right. It's always the same. It's like, how many of you know smoking is bad? How many of you smoke? Would it be fair to say that, have you ever heard, I don't get paid to write unit tests? No? I don't get paid to write if statements either, but I write them. Imagine the guy that goes on a plane. It's like, I paid for this flight. I didn't pay for you to test this stuff, right? Impact analysis helpers, or how I can determine what things are going to change. There's a bunch of tools. One of them is ndepend. How many of you know of ndepend? That's a very good tool, because what it does is basically analyzes your code, and it tells you what module has dependency on what module. And if you get a graph that has a lot of wires going back and forth, that's kind of like a no-no. That's a little bit of an issue. So you want to kind of isolate things as much as you can. Another is my favorite tool of all time. I don't know if you've heard of it, called ReSharper. And, pardon? It's called ReSharper. There's alternatives out there as well. You can use any of them. Just don't use find and replace in Visual Studio. And the find result, ReSharper works with find results. So you can search for implementations of a specific type. You can search for all of the different, like for example, if you're looking for an interface or you're looking for a class and you want to see how many implementations of this there are, because as soon as you change an interface to that class or whatever, it can impact. It's very good in finding all these aspects of your code. And it's things you need to look at before refactoring. There is the refactoring without tests issue, though. How do I refactor if I don't have tests? Because that is a problem. Because if I change something and I don't have a test, how do I know if what I've changed works or not? And that is a fear that we have, and that's why we don't touch things. And the reason often we don't have tests is because it's too hard to isolate. We say, well, I can't test this. It's too hard to isolate. But here's a fact for you. An integration test is better than no test. If you cannot isolate something, just write an integration test for it. And replace some of those integration tests to make it faster. One of the main reasons, do you know the difference between a unit test and an integration test? Unit test ideally tests one thing in isolation, so that when I run that test and something fails, I know what's failed. What? That thing that I'm testing. And it's also fast. Integration test tests integrated components of the system. Right? So if something fails, something of those have failed, and I've got to figure out what it is, and also it goes slower. But having no test is not better than running an integration test, especially when you're doing refactoring. So while in the beginning of my career in terms of unit testing, I was like saying, okay, I have to do unit testing of every single module, and then I've got to write integration tests of all combinations of modules together, and I end up with 7,000 unit tests for 5 lines of code. Now I've moved more towards the, maybe I can just not use so much mock objects, and maybe I can just use in-memory databases. Maybe I can replace some mock files, or maybe I can replace some HTTP calls with my own dummy class and stuff like that, and focus more on integration tests and have them run and just speed things up. If I speed things up, it's okay. It's a compromise. Because then what happens is that the only thing that I lose, right, versus unit testing is if something breaks in that test, I've got to figure out what it is. Versus in a unit test, normally it's immediate, right? But a little stack trace analysis doesn't harm anyone, right? So move a little bit more towards integration tests, and if you can, just isolate some things to make it faster. Focus on making the integration test faster. But have integration tests, because they really are beneficial, especially when you're refactoring, especially if you have no tests at all. You can use code coverage for non-happy paths. What does that mean? Code coverage is normally focused around, oh, I've got unit tests, so I'm going to run code coverage on these unit tests to see what percentage of my code is covered by tests. And if it hits 70%, I'm doing good, right? Because the exact percentage of code coverage, which is valuable, is actually scientifically, again, proven that it's 73.8%. If you hit that mark, you're good. If you're at 73, I'm bullshitting you. Okay, good. There is no, the code coverage has never been about percentages, and has never been about seeing how much of my code base is covered. I've always looked at code coverage as a means to find out if there's something that I have not covered that has a potential problem. In other words, when I run code coverage and I see 40% no coverage, I'll look through that 40% and see, okay, well, I don't care about this line of code. Maybe I don't need to cover it. So if you look at code coverage, and this actually looks really nice on my screen. It doesn't look nice there, because these lines here are green. They've got a green background. These lines here are pink, which you can barely make out. So anything that's white here, because you can't actually see the green, can you? No. So these ones actually have a green background. Those ones have a green background. This one has a red, right? And this isn't unit testing. This is, I've used a tool that I've run coverage. I've run my application. I've gone through a series of scenarios, and it's given me coverage. And what it's saying to me is that these lines here are not, have been hit when I've done that scenario. These lines have not been hit. So without unit testing, I can still cover my code and see if I've refactored, and I thought that when I refactored, this should have been hit, how come it hasn't been hit? Right? And it's an ideal way to find bugs. Just running code coverage on your code base, not even your tests, and seeing, why isn't this not being hit? I found so many bugs like that. Like, for example, one time I wrote this sophisticated DAO that had a rollback mechanism of several layers, and shipped application version, it was working, everything. And then one day I realized that rollback was never even ever being called. How is that possible? It was working, but I found the potential bug. Detecting code smells. Because when we refactor, we also got to see what things we want to take out. What are the problems that we want to focus on? If I've got a really large code base, I want to see what issues I want to improve. So we got to detect those code smells. And what are code smells? Well, first of all, the less is more, or also known as single responsibility. How many of you know single responsibility? Right. Who can tell me what it means? Go ahead. Class should have, no, but tell me the principle. Right. Class should do only one thing. A class should only be responsible for a single thing. Okay. What is that thing? That's the key question of single responsibility principle, right? Where do I draw the line on that thing? I've got a customer class, and it creates customers, it deletes customers, it writes invoices, it sends customer reports. It does everything to do with customers. It does one thing, customers. That's all it does. Is that a valid single responsibility principle? No. So what he was saying is, well, a class should only have one reason to change. And we'll get to that, right? But before we get to that, symptoms you're breaking single responsibility. Now, I don't have that actually working, but this is an example. This was a video that I recorded because I couldn't fit it on the screen. It was a class with like 7,000 lines of code, right? And it was just recording through the video. It's actually from an application called ERP Store that's on Codeplex. You can look through some of the classes. Although the guy, after he saw that I've been talking about his code a little bit, he has improved it. But you know, it's good because it's constructive criticism, right? This was a very, very long class, and it did absolutely everything. Symptoms you're breaking single responsibility principle is if you use a plugin called RockScroll, right? How many of you have heard of RockScroll? RockScroll, and Sublime Text has this feature too as well, is basically a plugin you have for Visual Studio that here, Hanselman even wrote about it in a nice blog post, where you can, this is a preview of your file, right? No, I don't need to have a preview of my file because that's indicating that I've got way too much in my file, way too much. And people say, RockScroll doesn't work with ReSharper, and I'm like, who cares? You don't need RockScroll. RockScroll is putting a patch on a problem. It's not fixing the problem. You're just using RockScroll to have a preview of your file because it's so large it doesn't fit on the 3,860 pixel screen that you now have, right? Regions. That's another symptom of breaking single responsibility principle. Often, right? Do away with regions. They're evil. There's absolutely no reason in life to have regions. Nothing, except if you want to hold license information at the top. Absolutely nothing. This nonsense of, oh, I'm going to decorate my interfaces and my properties and my member. Oh, come on. The last thing I want to do when I look through Codebase is click that plus sign. And often, regions aren't used to hide this information, but they're used to hide other information that doesn't belong in that class. So let's solve a single responsibility principle. And the first one is reason for change. Take a look at your class and see how many reasons are there to change that class. And the more reasons, the more problems you're going to have. Because if a class changes for various reasons, that means that if I make a change, it can potentially impact that class, because that class can change for multiple reasons. If the class only changes for a single reason, when will I know if that class will change? Or when will it be impacted? When I change it for that reason. Are you following me? Or too many reasons and changes, am I saying? Right? The less number of reasons a class has to change, the less probability there is that it will be impacted by a change you make in the system. It's that simple. That is the only reason that we use single responsibility. That, and to make it easier to understand. If I look at a class and it does 100 things, it's harder to read. It's harder to maintain. It's much easier to have two classes that do two different things versus one class that does multiple things. It also allows for better modularity. It also allows for better reuse of code. So the reason to change. Then there's naming. Okay, and I used to make a big mistake with naming. I mean, not as big as these people calling their kid Apple, but I used to say, oh, I'm going to create a class and I'm going to call it A. And I'll give it a name later. How many of you have done that? Or just given it some name and said, oh, I'll just change it later? Right? You've not done that. Good on you. If you look at a class and you look at the methods, what you want to try and see is how cohesive those methods are. Okay? How many of you have classes that are called blah, blah, blah service? Blah, blah, blah utils? Blah, blah, blah manager? God, there's only one guy. Wow. What do you name your classes? Anybody ever use service in their code base? Manager, utils, helper. Why are you naming things helpers? Because all the other classes are just a-holes? And the only ones that help actually is the helpers? And then we get Microsoft shipping that nonsense, and we're like, oh, well, if Microsoft does it, it should be okay, right? Why are we naming things helpers? I like to, and I'll come to the name in a second, but look at the cohesion stuff, right? There's a feature in ReSharper which says, make methods static. So basically what it does, it looks through your class and says, well, you have a method that does not use any instance variables. Do you want to make this method static? I normally don't make methods static, but I do use this in a different way. I use this as a sign of a smell that maybe that method does not belong in that class. So how cohesive is your class? Do an experiment. Take your class, take all of the parameters that you have in your methods, and make them instance fields, right? So instead of using parameters in the functions, just have them as instant fields, and have the functions share these instant fields. You know, everything that's bad, like maintaining state, do that. Now look at your class and see how many of those instance fields are used by more than one method. If I have 10 instance fields and 20 methods, and 15 of those methods use 3 instance fields and the other 7 are unused, you start to see how much cohesion there is between the different methods in your class. It's just an experiment. I'm not saying that you should stop using parameters and move to instance fields. But it's about how cohesive your methods and your instance fields are together. How much information do they actually share, right? So when you have this method static, it's saying that maybe this method does not belong in this class, right? Because it doesn't really use anything of this class. Maybe it doesn't belong in that class. Then there's emergence through naming. It's trying to find responsibilities and trying to isolate code, trying to refactor your classes to have a single responsibility by naming them accordingly. And when you use things like manager and util and helpers, what goes is a tendency of putting everything in there. It's a helper class, I'll put everything in there. It's a util class, I'll put everything in there. But there's a problem with that we don't really appreciate. You know that you have a method that is a helper that is in a class called string helpers. I don't know that. And when I come onto the project, and the project is 60,000 classes, and I want to add a little helper method of my own that does something similar, and I know that your naming is not too good, what am I going to do? I'm going to create my own helper class, and I'm going to create my own method that does exactly the same. Because I don't name things properly, because I just add a suffix of helper and just hope for the best. Why don't we name things properly? Why don't we say, you know, what does this class do? Calculate estimation approval. Well, call it calculate estimation approval. No, we'll call it calculate estimation approval service. And then we'll have a method called execute. Apply single responsibility on methods. Far too often I see people not doing that at all. They just don't apply SRP on methods. They just apply it to classes. They think it's only available to classes. So for example, I have a method like this. Do something and do something else. And that is if what to do something else, do something else. Why is there a reason to have that? If you have and in your method name, it's an indication that you're doing too much in that method name. Now, there are rules that says, oh, a method should only have 3-4 lines of code. Well, yeah. If you have 100 lines of code, try separating those two methods up in 2. So using Booleans, using any type of parameter value to use as a conditional to decide what to do is normally a code smell that I could just do 2 functions and name them appropriately what they do. So refactor these things out. A tool that uses that is, again, ndepend. It's very good for that. And what it allows you to do is look for methods that match certain criteria, like cyclomatic complexity, like number of parameters that are being passed in. These things you can find easily with ndepend. Interface segregation, that's another good example of things that we need to refactor out. This is a simple interface: forward, reverse, left turn, right turn, take off, and land, right? And if I were to implement a car, that's what I would find. Now, no one in their right mind would write code like that, would they? No. Well, yes, they do, actually. If you've ever implemented a membership provider in ASP.NET, that's what you come across. I need 2 functions. I need my own membership provider for this. Okay, implement a membership provider and just implement these 2 functions. Do you realize that what we're doing is completely going against everything that the principles are telling us to do? In essence, an interface is what? It's a contract. And we're saying this interface has these methods, which means it abides by these contracts. Oh yes, but we only use 2 of them. Right? I'll rent you my house, but yeah, don't worry about the 7, 8, 9, and 10 clause. We'll just stick to the first 4. If an interface is a contract, if I'm reading this code and I see, oh, a car, an iVehicle, oh, take off. Now this is not implemented. You could be nice and say, not needed. I don't need this method. Or you can be really nasty and just delete the code here. Since I'm not returning a value, it's fine. I'll just delete the code and I'll leave the method blank. And then, of course, 2 years go by and someone else is looking at the code and they're like, this doesn't work. Why is this method blank? Maybe I should implement this method. Where is the documentation? There is no documentation. Where is the test? There is no tests. So why am I leaving methods blank? And the problem with this is that we need to refactor out these kinds of interfaces. And that's what the interface segregation principle tells us to do, is make smaller interfaces more concrete on what exactly those are doing. Basically, it's applying single responsibility principle to interfaces. I now have a reversing vehicle, and I have a flying vehicle, and I have a land vehicle. And then when I implement a car, well, then I'll do implement iLand vehicle and iReversing vehicle. And when I implement an airplane, I will do an iLand vehicle and an iFlying vehicle. Right? So you need to refactor these things out, because if I look at my code, look at your code base, and I see interfaces with 30 methods, it's harder for me to know what I have to do and what I don't have to do. It's harder to name those interfaces. How can something do 30 things? Often very hard. And the problem is that this leads to other issues. You know, I have a talk next week which is modularity. It's about how to create like little pieces of code that you can reuse and not have to reinvent the wheel each time. And a lot of times, the reasons behind this isn't some secret, but it's how we design applications. We create these larger classes, larger interfaces, and then when we want to reuse them, we say, well, this isn't quite the way I needed it, so I'll just create a duplicate, or I'll just change it in this way. And if we abide by these kind of principles, we do single smaller things that we can classify as modules that we can reuse. Dealing with dependencies. So I have a class, then that class talks to a database or talks to a socket server, and I need to refactor it. And now I've run into an issue because I don't have a database, I don't have a socket, I don't have a unit test. I need to refactor that. But I don't have a unit test. What do I do? I can, yeah.
Dependency injection, mocking provider for database.
Yeah. So how many of you are familiar with dependency injection? Okay. So the first thing that you can do is just, as parameters or whatever, if you're making a method call or whatever, is just pass in the null object and hope everything is good and, you know, nothing breaks. The next thing is extract interfaces. And just, you know, those dependencies that are being passed in, extract them out, and then provide interfaces so that you can replace them. And if all that fails, you can use type mock or moles or something that allows you to override behavior. But when dealing with legacy code, how do we do this dependency injection? Do we do dependency injection or do we do service locator? Do you know the difference between the two? So dependency injection is basically, if I have a class, let's say I have a, I'll call it customer management. That's a good name. Customer management that talks to a database. So that customer management talks to a database, so therefore I have my database access abstracted in another class. So the customer management now, in some method, instantiates an instance of the database class and talks to my database. That's a no-no, right? That's a big no-no, because now it's very hard to test that. It's very hard to change the database, because now I would have to touch that code and change the code and instantiate a different class, etc. So the way we solve that is by dependency injection, which basically means instead of the customer manager class creating an instance of the customer DAO class, the customer data access class, we pass it in as a parameter to the constructor. So I can change that. And better than passing in a specific class, I can pass in an interface, so I can now have different implementations. That is dependency injection, basically. It's just passing parameters to a constructor of the dependencies that that class needs. Back in the old days, instead of that, or still, instead of passing in dependencies, what we can also do is just create what's called a service locator, which instead of my customer manager class creating an instance of the customer data access class, I delegate that to a factory. And I say, create data access. And then I can configure that factory somewhere else in the application. I don't favor service location. Personally, I prefer to use dependency injection. And although it's easier a little bit to say, yes, in legacy code, service location is easier to implement. Why? Can someone tell me? Well, because with service location, I don't have to change the interfaces of the classes. I don't have to add parameters to constructors. So therefore, I break less things. As soon as I use dependency injection, I got to change the parameter of a constructor, which means now half of my project won't compile. Right? So in essence, yes, it's easier to do, but in the long term, it's going to lead you to more problems, because eventually you got to get rid of service location. And dependency injection also is good in that not only does it allow you to isolate your dependencies, but it also gives you code smells. Right? Here is an example of order controller from real code, which is the example I was talking to you about before. And if you look at this and you see 1, 2, 3, 4, 5, 6, 7 dependencies being passed into that class. And I've seen this way too many times. But it's okay. I'm using dependency injection. Surely this is fine, right? Because I'm using it. I'm doing everything the book says. I'm passing in my dependencies. Yes, but you're passing in 7 dependencies. What does that mean? That means that the class that is using these dependencies has tight coupling to every other class that is being passed in. Sure, it's not going to use a specific type of encryption, but nonetheless, it depends on the encryption service. And if you have these types of graphs throughout your application, you're not accomplishing much. You're using dependency injection, you're configuring it using an IOC container, but at the end of the day, you got tight coupling, because everything depends on everything. So when I use dependency injection as opposed to service location, it also provides me as a code smell. Because if I see that a constructor is taking in more than 2, 3 dependencies, that's a sign that this class is probably doing too much. So when you are, if I say, basically what I'm saying here is that I recommend in legacy code bases to start with dependency injection as opposed to service location. The problem is, of course, that I start to break too much of my code. And what you can do there is use what's called poor man's dependency, which basically is create a parameterless constructor that creates instances of your class and one that you can pass in dependencies, and then gradually remove those parameterless constructions. That also brings us to the question of IOC. Now, IOC containers, basically what they do is configure all these graphs for you so that you can just do this. You can do this, and magically the IOC container is going to fix it all up for you. Fantastic. Recently, there's been talk that, oh, IOC containers are bad because they allow this kind of behavior. No, this is bad developers allowing this kind of behavior. IOC do their job. It doesn't mean that you have to do it badly. So I am all in favor of using IOC. And all of this is to minimize change and impact. Here's another one of minimizing change and impact. This kind of code we need to refactor out. Yeah, what does this do? Based on state, it does different things. And of course, the problem is that I've got this type of code repeated in several places in my code base. Right? This type of code we can refactor out. Can anyone tell me what we can replace this with? If I'm in this state, do this. If I'm on this state, do that. If I'm on this state, do that. What can we replace that with? It's a pattern. Drying up things. Here's a simple example that I like to refactor out. This is an ASP.NET MVC application, right? And I often see this. If employee equals not null, return view, else redirect not found. I see this many, many times. So you look at code and you constantly see repetitive code at the beginning of a method. The problem with that is that you won't solve that using something like resharper templates. You shouldn't use resharper templates to generate boilerplate code that is constantly repeating. That's the wrong thing to use, right? That is solved using a different problem. That is solved using aspect-oriented programming. Are you familiar with that? Right? So basically, put it a simpler way. Attributes. Everyone knows attributes, right? You can use attributes to solve that problem in ASP.NET MVC. Basically, I'm saying that I'm going to use AOP. If you're not familiar with AOP, what is AOP? Every class has a single responsibility. Okay? Customer does one thing, employee does one thing, invoicing does another thing, etc. However, there are certain aspects of a class that are cross-cutting. There are certain things that all classes have, like security, like checkings, logging, etc. Those aspects you have to extract and use AOP. I'll talk about this in a second. But first step is to find this kind of code, is to find repetitive code. And again, you can use tools. ReSharper allows you to do that. I think other tools allow you to do that as well, which is searching for code that is very similar. Right? I think even Visual Studio has now some functionality which is allow duplicate code. Okay? In ReSharper, we've got even a better one, which is pattern, which basically allows you to define your own pattern with your own conditions and then search globally for those patterns, detecting code smells. That's called the custom patterns or search and replace. So I can say, look for this kind of code, and then it'll tell me, oh, you've got this type of code in several places. And notice that here, it doesn't care about the name of the variable. It just detects the type of pattern. And then you can replace that. And when it comes to replacing this kind of functionality, is dealing with repetitive code, you ask a series of questions. What functionality am I replacing? What is it doing? So I have to first extract that functionality. Then I have to evaluate the responsibility of that functionality. Is it a method? Yes. So I can just create a method in that class and have that, all of the other methods call that method. Fine, we've all done that, extract method, refactor to extract method. However, if I find that that kind of code is being repeated across multiple classes, then I'll create a helper. No, I'm kidding. I'll create another class, I won't name it helper, I'll create another class that does exactly that. But the question now is, how do I pass this class over? How do I have all of my classes use this class? And there you have multiple options again. You have dependency injection, right? I can use dependency injection. You can use tools like AOP frameworks or aspect-oriented programming, right? Which allow you to basically inject code into other classes so that those classes can use them without passing them in as dependencies. In .NET, AOP can be accomplished using things like attributes. Or you can use post-compile tools that weave in functionality to a class. For example, have you heard of PostSharp? Right, PostSharp allows you to do something like that. You can also use AOP with IOC containers. How many of you use an IOC container? Like, what do you use? Structure map? Yeah. So structure map allows you to intercept functionality by passing in other classes. And you can say, when a method is called, I want you to first intercept it and call this other method. So you can use that as well if you're using IOC. You see, IOCs have more benefits than just wiring up things. Other things that you have to deal with in refactor is composition over inheritance. That's a big problem, right? Especially when we have these kind of, what you call it, long inheritance chains. How much time do I have left? I still got like 10 minutes, right? Yeah? We're good? Good. So if I have composition over inheritance, if I have a bunch of classes and then one class inherits from another and then another and then another and then another, you have this long hierarchy of classes. And what often happens is that you end up with like the third or fourth class in the chain having a series of methods that it's inheriting that it doesn't need, it doesn't require, it doesn't use, but because it's somewhere in the chain defined, that class is getting it. And again, this leads to readability problems. This leads to understanding. Why do I have these methods? Oh, they're inherited. Why do I have them? Well, because we kind of needed 60% of the functionality, and then we got this 40% added as a bonus, which we don't use. But all that, again, leads to single responsibility. All that leads to interface segregation, etc. And in essence, one way to avoid that and one way to avoid other problems that you'll encounter is to try and favor composition over inheritance, because that way you can pass in dependencies as well. So instead of having one class inherit from another class to use the functionality, just pass in that dependency, pass in that functionality, as opposed to creating inheritance chains. One other way that allows you to lower the side effects of code, and again, something to use when refactoring, is command and query separation. And I'm guessing that you've heard now it's very big in the space, the CQRS, which is command and query responsibility separation. This is the same thing. This goes back to old days. It's been around for many years. This principle has been defined. It was defined by Mayer for, what was the language? I don't remember. What was it? What was the language that he defined this in? It wasn't Smalltalk. It was, I can't remember. Anyway, basically what this says is that we need to have methods that either do something, which means do something is alter the state of a class, and methods that return values. So we separate commands. Commands are methods that alter the state of a class from queries that return values. What this allows us is idempotent calls. So that means that it doesn't matter how many times I call a query, it should never change the state of a class, which means that I minimize side effects. Right? Typical example of something breaking this is returning a numerator. And every time you call a numerator, it returns the value and increments it by 1. That breaks this principle, because if I call the numerator twice, the value of that numerator has changed on each call. Right? And the idea here is that if I have commands separated from queries, if I have functions that do things separated from functions that return values, I know exactly when I look at code base, anything that returns a value will never have a side effect of changing the state of an object. And this same principle is now being applied at a architectural, I won't say architectural level, but at a higher level in separating reads from writes, which is essentially what it is. So CQRS is applying the same principle in data access, right? I have, from one side, I have my writes, which are commands that update my database, and from the other side, I have queries that read from the database, which then leads to, why do I need an ORM? They're no longer necessary. But it's the same principle. It's separating these two to make it clearer and more understandable of exactly the impact that I'm going to have. And also, obviously, it also abides with the applying single responsibility to methods, which is just do one single thing. Okay? When you're introducing a new feature, do you TDD it or don't you TDD it? No? How many of you use TDD here? One guy. So Test-driven development, if you're not aware, I mean, you all know what test-driven development is, yes? How many of you know it? Everyone? What is it? Can someone tell me, apart from you? Okay, what else? Who else? Who agrees with that? Okay. So do you consider it a test, what you're writing? Defining the features, right? So TDD is more about defining the specifications, more about defining what you actually, the functionality. Yeah, it's about using the functionality before writing the functionality. That's in essence what it is, right? That's what I'm doing. I'm setting up a harness, an isolated harness in which I can simulate using something before actually writing it. Why? Because how many times have you written a method and then you've come to use it and you've realized, oh, the way I've called it or the way the parameters I've passed in, etc., aren't appropriate. I should rewrite it. Has that happened to you ever? Yeah. So that's what TDD is about, kind of. It's about saying, here, use it and kind of see if that's the way you want it, and then write the functionality. So you define, you shape, you define the requirements of the system, of the modules, etc. So obviously the question arises is, I've got a code base that hardly has any unit tests or has some unit tests. Do I use TDD to drive this or not? Well, I always look at TDD like an insurance policy, right? Because forget the fact that you're doing kind of, you know, design or whatever. I often find that the teams that, or even myself, that when I say, well, I'll tell you what, I'll just write some code and then I'll write some unit tests afterwards, those unit tests hardly ever come. Hardly ever come. So it's like, you know, I have no insurance. When I now go and refactor, I have no insurance. Whereas with TDD, I first write the test, which means that now I have some kind of guarantee that as I refactor, I have a test in place. And I don't go back to it later and never write that test, which is a problem. So if you can kind of push it out with TDD, it's better. Also, TDD leads you down better design paths, because when you're writing a test and you want to test something and you try to set it up and you start to see that there's so many dependencies and so much required to set it up, that's where you start to think about, how should I actually write this code so that it doesn't require so much effort from my part to set it up. So it does lead to a little bit better design. There's a whole bunch of other things. I mean, I can't cover everything here. There is the law of Liskov, which I recommend that you look at. The law of Demeter, which is when you have these, A should talk to B, and then B calls a method of C, and then C calls a method of D. You know, only talk to the privates of your or don't touch the private parts of your friends, or something like that. And the principle of least surprise. And this is a one that I often find that breaks. There's an example of this in Asp Net Mvc in the HTML helpers, which is the model validation. So there's a method whereby I pass in a class, right? I pass in a class which has a bunch of properties, and I call validate. And what this method does is basically print out, when it renders an HTML page, it prints out the input for the field of that class. It prints out the span, and it prints out some CSS, for instance, right? A title, no, it prints out the span, some validation code, and an input box. So I pass in a class, and for each property of that class, it prints out 3 elements. Okay? Why? Because what it does, it's a helper to do validation, so that if I submit some information and hit submit, it says, no, these fields are required. If you pass in, and that takes an object, which means it can take any class or it can take just a single property. I pass in a name, and I expect what? What would you expect if you pass in name? That it does the same thing, but only for name? Right? That it generates an input field, a span tag, and some validation code for just the single property? No. If you pass in name, it only does the input field. And that is breaking the principle of least surprise, which is Don't change the behavior of a method based on the parameters. Because as a developer, when I look at something, and I have now, if you pass in an object, it does this. If you do that, it does that. If you do that, it does that. It completely breaks the principle of least surprise, which makes it hard for me to determine what exactly is going on. Welcome to the world of JavaScript. JavaScript developers love to do that. They're just like, yeah, here's a function, no parameters. You just dump in parameters, and based on the parameters you pass in, I'll figure it out and do whatever I want. Okay, that's fine. It's wonderful that it doesn't matter how I pass in parameters, you figure it out. But how the hell am I meant to know what I'm meant to pass in? How do I know how the function behaves based on what I pass in? We go to great lengths and efforts to constantly say that, you know, we shouldn't write documentation, we shouldn't comment codes, code should be self-documenting, and then we go and write these obscure methods that you don't know what it's doing. So don't break that. Recommended reading. This is I have not touched a lot of the topics that Michael Feathers touches on working effectively with legacy code. This gives you concrete examples of refactoring, but it more or less is in line with what we've talked about, but with concrete examples. So, you know, we always are going to end up in this situation. Always. Even when we start a greenfield project, we're always going to end up in a somewhere like this, right? The only purpose here is to make it look a little bit cleaner and more tidy. And I ask, how to prevent from happening again? How do we prevent it? Because now we'll go with the best intentions, and then we will do it again and again and again. And I found this quote from this blog post, which I really liked, and it says, when adding a feature, the goal isn't getting from A to B in the simplest way. The goal is to make the code at B look as simple as possible. You're not done when all your tests pass. You're done when all your tests pass and the code looks as if it wasn't designed from the beginning with your new feature in mind. And here's the key, right? You're not done with a feature when all your tests pass. You're done when all your tests pass and the important part, the code looks as if it was designed from the beginning with your new feature in mind. And that's an important thing to think about. If every time I design a new feature, I make my system look as if I had thought about this from the beginning, it means that I have very few hacks and things added to my code. So it's good to think about when you're adding new features or refactoring. And with that, I am done. And I think we have 43 seconds for questions. Nope? Okay, well then, thank you.